have completed EBS dynamic provisioning and EBS static provisioning. Now we'll work on EFS static provisioning and dynamic provisioning as well. So VIM EFS static provisioning. So static provisioning, we have to create PVC as well. So in the EFS file storage class, no need to provide any EFS storage class name because this is a static provisioning. So static provisioning, no need to mention any storage class. So here from 30 GB PV, from 30 GB, I'm asking 10 GB claim. So you can mention claim name here like this. EFS static PVC. EFS static PVC. So it is taking 10 GB storage from PV, this pod. So here I'm mentioning load balancer means external access, giving external access to the user. That's why. So we need to create first file system, EFS file system. Go to first remove this ID, volume handle. First go to EFS, create file system. So give cluster PVC, virtual private cloud. If not providing this cluster PVC, this EFS file will create on default VPC. So default VPC means other VPC. So if you want to communicate one VPC components to another VPC components, you need to do peering connection. So that's why I provided EKS cluster PVC directly. Within the PVC means communication will happen automatically. Means getting access. So మనకి యాక్సెస్ అనేది వస్తుంది సేమ్ VPCలో ఉంటే. అదర్ VPCలో ఉంటే కంపల్సరీ పీరింగ్ కనెక్షన్ చేస్తేనే ఒక VPCలో ఉన్న కాంపనెంట్స్ ఇంకో VPCలోకి యాక్సెస్ చేసుకోగలుగుతాం. So file system is going to be creating. Refresh. Yeah. This is the file system ID. Take this file system ID and place into this volume handle section. So check once PVC. This is a claiming that PV EVFS static PVC. From PVC, it is taking 10 GB storage. Or you need to install CFS, yeah, EFS drivers, EFS CSI drivers. CSI means container storage interface drivers. So find here. These are EBS. So go and check from Google EFS, EFS, CSI drivers, CSI drivers. So here we are using static provisioning. So go to GitHub. These are the EFS CSI drivers. So find installation section. This is the version, latest version. So find static provisioning means you need to create PVC. This is the syntax. I have mentioned file system ID like this. Where example static provisioning. So we need to find installation examples. So I have taken backup. Yesterday I have taken backup. Just 1 minute. Listening EFS file system provides security groups. Missing. This is EBS zone. Find here only somewhere installation steps are there. You need to find docs. Yeah. Yes, this is the installation. Amazon EFS ESA driver version. So this is the latest 2.0. Copy. Copy this one. Now driver is going to install. The EFS CSI drivers installed. Check kubectl get pods -n cube system -system. So all are ready. Desert count is 3 by 3, right? So CSI drivers all are ready. Next task, go to file system, networks, take the security group ID, find security groups, so is the default. Hey. Point networks where it is created default default security group. Okay. Allow all TCP. inbound web, provide or TCP. Now updated. And also go to EC2 instances. These are the running, take the manager node, find role, provide EBS full access, EFS, not EBS. Attach policies, elastic, elastic, file system full access. See, find here, elastic file system full access. Now added. Now deploy the EFS static provisioning file. Apply. -F EFS static provisioning. Need to check PVC, kubectl, PVC, get PVC, PV, comma PVC. See here bounded. From 30 GB is bounded unit. How we can check it is a bounded or not? So kubectl, describe, EFS static PVC name. So default namespace, bounded, bound, bound to volume EFS static PV. So here bind completed S and bound by controller. So those are mandatory. It's so used by Nginx. So Nginx pod using this EFS file system. Now kubectl, pods, get pods, -o wide. So it is in use. So you can check the console itself. Go to EFS, click on access. Is available, enabled. So backup enabled. So how to check this external file system is mounted or not? So if even Nginx pod deleted, our data remaining safe. That is the condition for when using volumes. సో మనం ఎప్పుడైతే వాల్యూమ్స్ యూజ్ చేస్తున్నామో పాడ్ పాడ్ డిలీట్ అయినా కానీ మన డేటా అనేది సేఫ్ అయి ఉండాలి. అంటే మళ్ళీ పాడ్ ఫెయిల్ అయ్యి మళ్ళీ రీక్రియేట్ అయినప్పుడు సేమ్ డేటా అవైలబుల్ ఉండాలన్నమాట. సో అప్పుడు యూజర్ యూజర్కి ప్రాపర్ డేటా అనేది డైనమిక్గా లోడ్ చేసుకుంటుంది. డీపీ నుంచి ఫెచ్ చేసుకుంటారు. ఇట్లా డేటా బ్యాకప్ సినారియో. ఇది స్టోరేజ్ మెకానిజం. సో ఇక్కడ ఏంటంటే kubectl exec -it nginx pod name -bash. Now we are in bash container. So check c/usr share nginx and html. So here list out. So no data. Create echo by using echo command. You can create one file, that is index.html. Welcome Carvilla. This is the redirect operator in the Linux command. So whatever file name given here, that welcome Carvilla text is placed to this and saved to index.html file. So list out cat index. So this data మనకి డేటా అనేది బ్రౌజర్ నుంచి మనం ఫెచ్ చేసుకోవాలి. సో దట్ ఈస్ ద టాస్క్. ఫస్ట్ కాపీ సర్వీస్, go back to pod host and get all hyphen get all. Hyphen. This service, the service section I have mentioned load balancer. So cluster generated load balancer after deploying Nginx pod. Access from this browser. The welcome Carvilla means our application going up. So up and running. We can able to access our data from browser. Next next task is going to do dynamic provisioning. So I'm sharing this location in the WhatsApp. You can keep somewhere because in this readme.file only installation things available. It is useful in future and companies while working with company. It is very helpful for finding this location. So next, working with dynamic provisioning. So down the all the resources except CSI drivers, kubectl, delete, -f, EFS, static, provisionable. It is deleting. Fully deleted. So try to create one more time because loaded from storage. If God crashes, it apply. Apply. Check the order. CTL, EXDC, CD, flash, USR, Air, Nginx, HTML. List out. So in the HTML, even the code deleted, our data remaining safe. That is the volume external storage usage. So means diagrammatically you can understand. Create one diagram for this. Storage. This cluster. Three case cluster. EC2. These are the pods. Nodes, not pods. So collection of nodes can be called as a cluster. So here hardware resources like this, sharing hardware resources, combination of hardware resources. So this is M5 means 4 GB RAM and 2 core CPU. So directly connecting better. Okay. PV. High created PV. This is PVC. Pod. PV, PVC, it is sharing volume 10 GB. So here PV mounting to external storage, that is a EFS file system. So this is the external file system. So even the pod crashes, only Kubernetes cluster understand that PV and PVC. These resources only Kubernetes cluster understand PV and PV can understand external volume. So that may be EBS or EFS or S3, any file system. So like this communication will happen. Cluster, collection of hardware resources means here 2-core CPU. Check one EC2 instance type. Instance type M5.large. So this is 2-core CPU and 8 GB RAM. RAM.